We have a table of values and a graph for the rest of these problems. Before we read the problems and try to answer them, let's just stop and interpret what we have. We have a table of values that gives us x values and some corresponding g and k values and the values of their derivatives. And we also have the graph of f. Obviously, it's piecewise. It looks linear. We'll assume that it is. And we are going to have to answer questions involving the derivative, which will be pretty easy to do if we know where to plug the numbers or find the numbers. We have derivative values here. We don't have derivative values here, but we can find them because anytime we're asked to find the slope of a graph, and it's linear, particularly in this case, it should be pretty easy to do. We'll just find the slope of the corresponding line that we're dealing with. Okay. Enough talk. Let's do this. So for h equals 2f of x g of x, evaluate h prime of 2. So here's what they're asking. Find the derivative of this thing and plug in a 2. Okay, fine. So what I'm going to actually do is just sort of take this in pieces, and instead of saying this is f and this is g, like this is the first part and this is the second part. So at the beginning of the lesson, like right under the title, where it said f and g are arbitrary, what I'm really saying is, in this case, f is this first part, which is 2f. And don't let that confuse you. Basically, I have a first part, I have a second part. And so when I take the derivative of this particular function, which we have defined, we've called it h, the derivative of that would be, well, the derivative of this times that plus this times the derivative of that. It's f prime g plus f g prime. Okay, let's say that again. F prime, well, in other words, the derivative of 2f would be 2f prime. F prime g, okay, well, that would just be g, plus f, which was just 2f, g prime. Okay, fantastic. Now we're going to find out what the value of the derivative is at 2. So we're going to plug in a 2. So we have 2f prime of 2, g of 2, plus 2f of 2, g prime of 2. Okay, so now let's start plugging in some numbers, finding some numbers. We have a table, we have a graph, we have fantastic stuff we can deal with here. I want to know what f prime of 2 is, not f of 2. Now f of 2 would be this value right here, which would be 1.5. But I want to know the slope at 2, and the slope at 2 is 1/2. Rise 1, run 2. So 1/2. Okay, well, what's g of 2? I don't know, but good thing we have a table. If x was 2, the output would be -4. You can't see what I'm writing. Now you can. Okay, let me zoom out a little bit. You can see a little bit more of it all at once. Plus 2. F of 2. Okay, f of 2, which we found out a second ago, would be this y value, which is 1.5. We'll call it 3/2. It's for fun. And g prime of 2, so plugging in a 2 to the derivative, and we'd get a 7. Running out of space here. So 2 times 1/2, that's 1 times -4. So -4 plus, and then these 2's cancel, 3 times 7, so 21. And that will give me 17. Okay, let's move on to the next one. For h equals, okay, they've redefined h. We have g divided by x squared minus 1. Evaluate h prime of 0. Okay, obviously we need to figure out the value of the derivative, first of all. Second of all, we need to figure out the derivative. Then we're going to have to plug in 0, but we're going to have to do the quotient rule. So in case you didn't catch the memo, and I'm sure you did, this one is the product rule. And this one's going to be the quotient rule. We have the product, we have the quotient, and there's a third one actually, but that's a whole separate lesson. We're not going to go there right now, as fun as it is. So h prime is equal to, okay, quotient rule says f prime g minus f g prime all divided by g squared, okay? Now, let me rephrase that. Top prime bottom minus top bottom prime all divided by bottom squared. So as I talk about f prime g minus f g prime, I'm really saying that's f and that's g. I know that's the letter g, but again, f and g are arbitrary. It's the placement of these things. So top prime, bottom, lots of parentheses here, minus top, bottom prime, all divided by bottom squared. F prime g minus f g prime, all divided by g squared. And so we're going to plug in a 0 now. Things are going to get really clean really fast. I think h prime of 0 is g prime of 0. 0 squared minus 1, that's fairly obvious, minus g of 0 times 2 times 0. Well, that's going to help us a lot. And that wasn't being sarcastic either. And we're going to have 0 squared minus 1, and that is squared. Okay, a lot of cleaning up is going to happen very quickly. Let's go for the obvious. G of 0, I'd love to find out what it is. It's 4, but I don't care because 2 times 0 is 0. That whole term is gone. So I have g prime of 0, which I do need. G prime of 0, which is also 0. Wow, this is turning out to be quite the problem, isn't it? We're going to have 0 times negative 1. If you want to, you could put minus 0. And all this is divided by negative 1 squared, which would just be 1. So that is 0. The whole thing just ended up being 0. You could say that this whole thing cancels as well. So that one's gone too. So we have 0 and 0, and it's just 0. The whole thing is just 0. All right, moving on to number 8. We see x times k of x, and I want to evaluate h prime of 3. They keep redefining h each time. Is this product or quotient? Well, x times k of x, that would make it a product rule. So here we go. Switch colors again. Let's go back to green. You were hoping for purple, weren't you? That'll be the next one. The next one's going to be nasty. You might cry. So we are dealing with the product rule, which would be f prime g plus fg prime. So we have, first of all, this is our first component, our first expression. Here's our second one. So the derivative is the derivative of x, which is 1. I'm going to put it just so we don't lose its place and be like, what happened? F prime g, so 1 k of x, plus x times k prime of x. And I want to know what happens if I plug in a 3. Let's go a little faster on this one. Save time for the last one. We'll need it. So k of 3 plus 3 k prime of 3. And let's see, k of 3, I'm looking in the table. I'm not going to slide up. You can see the paper. Negative 8 is what I get. You better get that too. K prime of 3 is negative 3, and so we have negative 8 minus 9. That's going to give me negative 17. Okay, let us move on to the last problem, which is going to involve 2 different rules all at the same time, kind of simultaneously. So the biggest thing happening is that I have something divided by something. So I'm going to say that this one is a quotient rule, but I'm halfway lying to you here, but we'll just go with it for now. So purple, because I promised. Let's go ahead and start by finding the derivative. Okay. Well, quotient rule is going to be something, all divided by g squared. So let's go ahead and do the all divided by g squared. Okay, that part's done. But now we're going to have to do f prime g minus fg prime. That's the numerator. And so f prime, and I don't mean f, looking at this f, I mean top. Okay, top prime, when I take the derivative of this, that's going to involve the product rule. Whoa. Okay, there's going to be a little product that's going to happen right there. I'm going to leave plenty of room for it. And this, in the parentheses, is going to be the product rule. Okay, I'm going to come back to it. So f prime, top prime, bottom, minus top, bottom prime, all divided by g squared. Okay, let's come back to the product rule. The product rule in this context is going to involve first, second. Okay, it's going to be x squared and f. And looking at our rule, let's not say f and g, let's say first and second. First prime second plus first second prime. All right. First is x squared. First prime would be 2x. First prime second plus first second prime. You can make all your lists of f's and g's, and that's fine. But considering the fact, and I did this on purpose, considering the fact that f is involved in something larger than just it being the numerator, I didn't want us to start assigning things as f when I'm really talking about the top or the bottom or the, whatever aspect of it is. There's more going on than just f and g. All right, back to work. So I'm going to plug in a -1, and we're going to figure this thing out. It's going to take a minute, and it is going to be a little bit sloppy, but that's okay. H prime of -1 is equal to, okay, let's do some things in our head. Let's just go ahead and jump straight to the fact that I know that 2 times -1 is -2, or -1 squared is +1, things like that, okay? So plug in -1 in right here. I have -2, f of -1, plus -1 squared is 1. I'm not going to put it. Let's just not, okay? F prime of -1, g of -1, plus -1 squared. We've already decided what that was. F of -1, g prime of -1, all divided by g squared. G of -1, all squared. Okay, let's figure out what this is. Let's zoom in a little bit here. And this is going to involve us looking at the graph, looking at the table, figuring out some values. So we have -2, f of -1. The value of the function at -1 is 2. Good for us. Yay. Plus f prime of -1. What's the slope of the f graph at -1? Down 1 over 2. Yeah, -1/2. -1/2. All that was in parentheses. We multiply by g of -1. That is going to come from the table. G of -1 is -2. Plus, okay, f of -1. F of -1, we've already decided, is 2. I'm looking here, but I'm also pulling my answer from there. There it was, it's 2. So 2. G prime of -1 is 9. All divided by g squared. G of -1, we already found that out. It was -2, but we need to square it. Okay, let's clean a few things up. We have a little bit of a mess to deal with, but that is okay. I need to make a correction on something. It is a tragic, terrible mistake that I am not going to refilm the video for. Hopefully you have caught it before me, and I was about to finish this thing and do it wrong. Okay, easy mistake to make when you have a lot of things like this. Actually, if you haven't caught it yet, pause the video, try to find my mistake. It is not numerical, okay? All my numbers are correct. Here it is. Should have been a minus. All right, easy mistake to make. Mathematicians do it all the time. Math teachers do too, obviously. I just did. We get so caught up in all the intricacies and did I have all my parentheses and all the stuff? That was subtraction the whole time. Be careful, he said to himself. All right, here we go. -4 minus 1/2, that's going to give me -4.5. -4.5 times -2 minus, we'll go ahead and call that 18, all divided by 4. Let's see, -4.5 times -2, that would be +9. 9 minus 18 divided by 4, that's going to give me -9/4. There we go.